Hello everyone. Today we will be learning about Unit 5, Lesson 1, Plotting Points. So let's get into this. René Descartes, a 17th century French mathematician and philosopher, revolutionized mathematics by developing a system for graphing ordered pairs on a grid. This system, known as the Cartesian coordinate system in his honor, allows for precise representation of points in a plane using numerical coordinates. The Cartesian plane consists of two perpendicular number lines that intersect at a central point called the origin. The horizontal axis is known as the x-axis, while the vertical axis is called the y-axis. These axes divide the plane into four distinct quadrants, which are conventionally labeled in a counterclockwise direction. So here we have our x-axis, that's the horizontal line, that is x, and our y-axis, which is the vertical line, is this one here. And when we draw these two, axes, we have four quadrants. Quadrant 1 being this one right here, 1, and quadrant 2, quadrant 3, quadrant 4. So it's like counterclockwise. Quadrant 1, both the x and y values are positive. So if you take a look at the numbered lines, it's positive 1, positive 2, positive 3, positive 4, positive 5, and the y-axis is positive 1, positive 2, positive 3, positive 4, positive 5, and so on. So quadrant 1 is all positive values for both x and y. Quadrant 2, however, if you take a look, the x-axis is now negative numbers, negative 1, negative 2, negative 3, negative 4, negative 5, and so on. So the x values are negative, but the y values are still positive 1, 2, 3, 4, 5. Quadrant 3, kind of the opposite of quadrant 1 in that both the x and y axes are both negative values in this quadrant. And then quadrant 4, we have the y values, which are negative, and the x values are positive. So important things to note. Here we have so in the system, every point is represented as an ordered pair, x comma y, where x coordinate indicates the horizontal movement and the y coordinate indicates the vertical movement. This system became a foundational tool in algebra, calculus, and physics, linking geometric shapes to algebraic equations and enabling the visualization of mathematical relationships. So we're going to give an example. So in our example, we have points 3 comma negative 2. Now remember, when we're graphing this, the first number is our x value and the second number is our y value. I recommend always, when you're new to this, writing out the x and y so you can visually see and you don't forget and make a mistake. So we're going to plot this point. How do we do that? Well, we go to our x-axis. I also recommend drawing an x and a y so you remember which one is x, which one is y. And now we look on our number line, our x-axis here, and find 3. So here we have 3. And for now, I'm just putting a dot here, but normally you wouldn't really put a dot here unless you plan on erasing it later on. Now for y, we look at our y-axis and find negative 2. And we plot the point where these two kind of sections intersect. So negative 2 here, 3 here, and then boom, our point 3 comma negative 2 is exactly here where this red dot is. And that's how you plot a point. All right, take a moment if you like to pause the video to try doing this on your own. We're going to plot a few points from A to J. Let's get started. As always, remember x comma y. X is 3, so I'm going to find 3 on my x-axis, and 3 is over here. And I'm going to find 4 on my y-axis, 4 is over here. I'm going to find out where these 2 points intersect, and it's right over there. So just so you know, you don't have to draw these dotted lines. This is just to showcase how I'm getting to that point. Let's do B. once again, x and y. In this case, we have -1 for our x-axis, so -1 is here. And we have +4 for our y-axis, so +4 is here. And we know that these points are going to intersect at this point right over there. So this is our answer there, and I'm going to get rid of these arrows so you can see what's happening. And there you go. So we got our B point, A point. Let's do green for C, X, Y. So once again, X, we look for 4 on the x-axis, and then we look for -2 on the y-axis. And that's down here. There you have it. Let's do D. I already did blue. Let's do black. -5, -4. So -5 on the my x-axis is right over here. And I know -4 is going to be going down 4. So I can just do it 1, 2, 3, 4. Do it that way as well if you want to. Or do it how I initially said, to find these 2 points and kind of find the cross section where they meet. If you were to draw a line from here to here, and they would meet at that point. All right, D is done. Let's go on to now E. Once again, X and Y. 2. So 2 is here, and 5 is my value for Y. 1, 2, 3, 4, 5. There we have it. That's 5, that's 2. We're good to go. X and Y for F, -3 and -1. So -3 is here, -1 is just one below. There we have our point F. And we'll have to repeat some colors. I guess I can pick a different color. Pick that color. X and Y, so -3 and 7 for G. So let's look for -3. -3 is here. And +7. 1, 2, 3, 4, 5, 6, 7. So that would be right there. And let's pick. We have green. I guess let's do light green. H, 6 and -2. Once again, our x value first. Find 6 and -2 we know is just down 2, so that's that. Pi, x, y. Starting with 2. So 2 is here, and then 0. 0 means we don't move up or down. And now we're at J, 0, -4. X, y. So if my x value is 0, that means, so if you remember the definition, x is your horizontal movement and y is your vertical movement. So if my x value is 0, that means I didn't move left or right. So I'm starting at 0. And my vertical movement is -4 or down 4. So 1, 2, 3, 4. So that would be right there. So erase these points there. And there we have it. That's our points A, B, C, D, E, F, G, H, I, J. Please check to see if you did it correctly. We're going to move on now. All right, we have another example here. It'll be a little bit quicker. So 1 and 1, it's going to be 1, +1, and up 1. S for B, -8, -3. Here we'll do a different color. We'll do red. -8 is to the left 8, and +3 for my vertical movement is up 3. So the positive negative also kind of lets us know the direction in which we're moving. So if we're moving in the positive direction for x, that would mean we're moving right. And in this case, we're We have -4 for y, so we're moving down 4. So 1 to the right, 1 to the right, and down 4, 1, 2, 3, 4. That's also another technique you can use to help you graph these. D is -5, -4, so -5 is to the left, -5, and -4 is down. 1, 2, 3, 4. And we can see that -5, -4. That makes sense. Here we have 2, 9, so 2 to the right, and all the way to 9 here. And we don't need to count, because we know 9 is there, we know 2 is here. So if you want to get like really large numbers, there's no need to count. You can just look at the scale to help you out. X, Y. So we have -5, -6. -5 is here. -6 is down here. -6, -5, yep. Here we have -3 and 10. So -3 is here, and +10 is all the way up here. There's no need to count once again. We have 7, -2. So my x-axis is +7. My y-axis is -2, so that's that point there. X, Y. Here we have 9, 0. So my x-axis is +9, and y is 0. That means I'm not moving up or down, so we're just staying here. And here we have 0, 3. And 0, 3 means my horizontal movement, or my x-axis, is 0. And y is 3, so it's going to be here. And there we have it. Okay, let's move on to example 3 here. So example 3, plot and join the set of points in order. Join the last point to the first point to form a closed figure. Identify the figure and calculate its area in square units. So we have D, E, F, G. So D is first, 1, 1. So 1, 1, that's over here. X, Y, so E is 1, -2. So once again, 1, and then -2 here. Now we have F. So this is D, this is E. F is -5, -2, -5, -2. Oh, that's here. F. And G is -5, 1. So once again, X, Y, -5, +1. That's up here. And they said to connect the last one to the first one and connect them in order. So my lines are probably not very straight, but I'm sure that's supposed to be a rectangle. Straighten that out a little bit. No, that's fine. So if that is a rectangle, how do I calculate the area? Area is equal to length times the width. Do we know the length and the width? Well, we can count. We know each kind of unit or box is going up by 1s or down by 1, regardless. So we can count. So 1, 2, 3, 4, 5, 6. So this is going to be 6. And this is 1, 2, 3. So we know this is a rectangle, 6 by 3. So if length is 6 and width is 3, the area is going to be 18 units squared. And if you're writing units squared, we say units squared because we don't know, the axes haven't been labeled if it's in meters or seconds or whatever. So yeah, let's move on to the next example.